Hey, welcome back everyone. So my name is Zach Vines, and what we're going to go over today to kind of segue away from our discrete probabilities where we were dealing with, cumulative, binomial, Poisson distributions, and everything like that in just the previous video. What we're talking about now is a normal distribution. So when we're dealing with a normal distribution, it kind of follows that bell-shaped curve over there where we have the mean is in the middle of the distribution. It's centered about the mean. The distribution is with 50% of the outcomes on the right side, 50% on the left side. So it's centered about the mean. One main thing I want you to hold in mind, especially when we're dealing with our Excel formulas here, and to distinguish it against the previous video with the discrete probabilities, is the fact that when it's continuous, we're really considering like the numbers between the numbers. And by that I mean before, we're dealing with counting numbers. So if we're dealing with a number of people, there's one person, two person, three people, etc., etc. But what if we're measuring something like rainfall, let's say, where I want to see how many inches of rainfall we have? Well, it's not just the case that it's either 0 inches or it jumps to 1 or jumps to 2. It kind of incrementally increases continuously along itself to where it could be, 0.1 inches of rainfall, then just a little bit more. And it's like a gradual increase throughout the increase in the rainfall. And so that's really the nature of it being continuous versus discrete. And so when we're plugging that into our Excel formula, which for a normal distribution we'll go ahead and say is just equals norm.dist, the input is extremely similar, but it's this reference point, this number in question, that starts to make things a little bit different, especially if you're comparing it against the previous video. We'll get into a couple of examples in just a moment, but it's going to look very familiar if you've been watching the previous video, where we have the number in question. That is our reference point. That's the probability that we're talking about. We're kind of locking that number in as our reference point. We have a given mean of the population, a given standard deviation of the population, and then whether or not we're dealing with a point or a cumulative probability. So again, 0 point, that's talking about the probability of a particular number, where 1 is dealing with that number and everything to the left of that number. So less than or equal to that number. You can make those perfectly synonymous with one another. So I think this is best illustrated as far as the nuance between this and the discrete distributions with a couple of examples. So let's go ahead and do that. All right, so for these examples right here, we're given the fact that this is a normal distribution. So we know that we're going to use our norm.dist formula like we just described a moment ago, where we have our reference point, our mean, our standard deviation, and then whether or not it's cumulative, if we're doing that number and everything to the left, or a point distribution, which would just be that number by itself. So in these situations here, we have a mean of 30 and a standard deviation of 3.5. That information is just given to us. So if we're asked, what is the probability that x is less than or equal to 3? Well, what I'm looking for right here, if I kind of map it out on my number line, is I want 3, so including 3, equaling 3, and everything to the left of it. Again, that's just the definition of cumulative, right? So if I'm just going to plug this in, this really doesn't change that much from our previous video with the Poisson and the binomial distributions, which were discrete in nature, where we're simply just going to make 3 our reference point. So I want 3 given a mean of 30, a standard deviation of 3.5, everything to the left of that. So when you plug that into Excel, it should just simply give you the answer for that. So that's not too different from what we just went over in the previous video, but what I want to show you here is something that's a little bit different because of the continuous nature of what we're talking about. So when, again, Excel is limited in that it's not going to be able to give us a function where we can find something greater than a certain number. We can find the probability of a particular number being the 0 or the point probability, or we're dealing with 1, which is that number and everything to the left. So we can work around it by doing 1 minus that number, just like we did in the previous video, to find the greater than aspect. But the reference point you use is going to be a little bit different. So here's what I mean. When we're saying p of x being greater than or equal to 3, well, what I want right here is 3 and everything that's greater than 3, okay? Before, and when we're dealing binomial and just discrete distributions in general, what I would do was I would exclude the part I don't want out of 100%, and it would leave me with what I did want. So here, what I would have done under a discrete distribution would go, okay, well, I want 3 and up, so let me get rid of 2 and everything before 2. So I would do, equals binom.dist, put in 2, and then the information that we have right here. But in this case, we're actually just going to put 3 right here with our mean, our standard deviation, and our 1. And the reason we do that is because under a continuous probability, which is what we're dealing right here, it's a normal distribution is continuous in nature. If I were to take, instead of the counting numbers before, where I'm going, okay, p of x being less than 3, if they're counting numbers, the first thing that's less than 3 is 2. So I'll take 2 and everything back. Well, under continuous, what's the first number that's less than 3? Well, if we're considering all of the infinite possibilities of numbers between numbers, where we have just an infinite number of decimal points we can tack on to something, where we have 1.11111067889, and then we have 1.3745. I mean, it's a bunch of different infinite possibilities of numbers in between numbers. The first number before 3 would basically be 2.99999 until the cows come home. So if that's the case, and I'm wanting to do, okay, let me exclude what I don't want, you can basically put 3 down as your reference point, and because the number right before it is that 2.9999 repeating, it's a negligible difference between the 3 and that number that's right before it. So if we simply put in 3 as our reference point, we find, given this norm.dist formula, if we didn't have the 1 minus, it'd be norm.dist 3, 30, 3.51. That would give us what we don't want. So 1 minus what we don't want gives us what we do want. So I know that might be a little bit confusing to look at first, but I think it's really important to nail down the concept of the previous video dealing with the discrete probabilities, because with those, you would go one number before the number in question and use that as your reference point, because that's the first number below the probability that we're wondering about. Whereas in this case, the first number before the probability we're wondering about, the 3 right here, is something so close to 3, we can just simply put in 3 and it's going to be just fine. So if anything, I think this is a little bit more straightforward and involves a little bit less thinking about it than the discrete. But whenever you're working through multiple problems at the same time, where you have to know whether or not it's discrete in nature or continuous in nature, you have to be able to delineate between those differences. So let's do one more example where we're dealing with a range of probabilities. And if you have these examples down, the examples down from the previous video where we're dealing with the discrete distributions, all of this should be a lot clearer. So let's get into that right now. Okay, so in this situation, you can see that, again, we have a range of values right here. So instead of just probability of x being less than a certain number or more than a certain number or equal to that certain number, we're wondering everything from 5, including 5, to 8, okay? So it's going to be very similar to what we've done before in the discrete distribution video, but again, it's going to incorporate kind of that different reference point we're using because these normal distributions are continuous in nature. So think about it like this. What we want is the area between 5 and 8, right? It's 5 less than equal to x, less than equal to 8. So I'm kind of segmenting off this section that I want right here. So if I were to find the cumulative probability of 8, that would be 8 and everything before 8, okay? That includes what I want right here. It includes that section between 5 and 8, but it also includes everything before 5 that I don't care about. So again, if I can remove what I don't care about out of the total, then what I'm left with is the part that I do care about. Here's the difference between this and the discrete distributions. What we would do before, since I wanted 5 and everything from 5 to 8 under the discrete distribution, I excluded 4 and everything below 4, because the next number before 5 was 4 under a discrete distribution, because those are individual whole counting numbers. Here, again, if it's continuous in nature, the first number before 5 is 4.99999 repeating. So my reference point, if I'm trying to get rid of this b right here, is simply going to be 5, because the difference between 5 and the 4.99 repeating is so negligible. If I just use 5 as my reference point, it's not going to result in much of a difference at all come the actual calculation. So essentially, to find a, which is going to be the whole here, 8 and everything before 8, it's going to be equals norm.dist. 8 is the number I'm locking in as my reference point. 30 is just the mean. 3.5 is the standard deviation. And I'm saying that that's cumulative because I want the probability of 8 and everything before 8. Less than or equal to means cumulative. So I get a number right here. And then I'm going to remove from this number what I get of the part that I don't want, this b right here. So I have equals norm.dist, and I'm locking in 5 and not 4 as my reference point, because again, the everything underneath 5 for a continuous distribution, you can pretty much make the reference point 5, and then it's going to take the 4.9, the 4.8, and everything before that. So that's the reason it's 5 and not 4 right here. But it's just going to be 5, 30, 3.5 from the information given, and 1 because that's 5 and everything before 5. And at that point, you just simply take what you got for A, subtract what you got for B, and that's going to be your answer. So again, I think it's really important to have the foundation down from the discrete probabilities first from our previous video. Once you have that down, really the only difference you need to worry about for calculating these Excel probabilities is the reference point is going to be more what I feel like most people would intuitively think it would be in the first place. Like when I see probability of 5 less than x less than 8, I'm just going to segment 5 and 8, and that's what I want right there. The discrete probability is what makes it a little tricky, because you go, okay, well, since they're whole numbers, the first number before 5 is 4, so I need to remove 4 and back from the total to get what I want. Here, you just put the number they say as your reference point, and you're pretty much good to go on that. But it's very fundamental differences between the two. Like I said, once you become a master of how to plug these into the Excel formulas, using the examples I just gave, using the examples from the previous video, the differences between the two become very simple, but it does take practice to start with for a while. So I hope that helps out. Please nail down those examples, and if you just continue doing that, I'm sure it'll turn out just fine. So thank you for watching.